Well, I think I'll start off with getting rid of this big two-section electrolytic. I don't think you can see it here, but stamped on this capacitor it says the red lead is a 40 microfarad at 150 working volts, and also the blue lead is another 40 microfarad at 150 working volts. But if you notice here, C11B says it's 40 microfarads at 150 volts. Okay. C11A section says it's 20 microfarads at 150 volts. So it differs from what's in the radio. Now this solar capacitor is the same brand that they use through most of this radio. I'm not sure what this brand is, but this solar, a lot of solar capacitors, and this looks original. And this one was 40 and 40. Okay. I'm not sure what to do, but I think the safer thing to do is I have both 40s and 20s. So what I think I will do is temporarily tack in C11A here. It says it's 20 microfarads. I think I'll go with what the schematic says. Then I'll try the radio. And if it doesn't have too much hum, or no hum, I'll call it good. You might wonder, well, why don't you just put what was in the radio? Well, the schematic calls for 20 and a 40. It could be that they didn't have 20s for some reason. They only had a 40-40, so they went with that. But the problem is, what I don't want to do is if I use a 40 and a 40, and this should really be a 20, it may draw too much current from the rectifier tube, shorting its life. Too much surge current. So I think if it doesn't hum, I think it'd be safer to put a 20 and a 40. And if it does hum a lot, well, I'll just take the 20 out and put two 40s in there, and just like the way it is in here. So we'll see how that goes. So that'll be the first step here. There's a screw holding, yeah, I guess you can see this. This is a screw holding this bracket here. This blade seems like it's too thick to fit in the groove. Oh, wait a minute, maybe not. Oh, I got it. I think it just barely fits in this slot, but I'm getting it. There it goes, loose now. Alright. Okay, now you can see that it says 40 and 40. I have to apologize if this lighting is not very good. I can't tell. Seems like it's washed out in the screen. Well, this lighting that I've been using in here, I don't like. It's I think it's washing out everything, so you can't see very well. So what I used in the kitchen in my previous videos was just a light I made real cheap, and it works out pretty good. But basically, it's just like a $2 work light with a clip, you know. And then all I did was take a piece of bed sheet and just duct tape it to the front, and diffuses the light and makes a pretty good light source. I'm going to try installing it in here and see if it looks any better on the camera. Okay, well, I've hooked up that other light that you just saw. It's a lot lower light level, but I think you can see things much easier. Hopefully that's the case. So hopefully now that you can see that this says 40 microfarads, 150 volts, 40 microfarads, 150 volts. So we'll go by what the schematic says and hook it up with a 40 and a 20. When all the parts came in, we put them all in these nice little plastic bags, individually labeled so you can tell what they are. I went with 22 microfarads. They don't make 20 microfarads, so 22 is close enough. The working volts is supposed to be 150 volts. I went with 200. Same thing here. The 40 microfarads is supposed to be 40 microfarads. They don't make 40 microfarads. So I got the next closest up, which is 47 microfarads. Working voltage, 150 volts. Again, 200 volts. So this should more than be satisfactory. And as you can see here, in the past I would just, these are much smaller than this paper. These are high voltage and this in the same rating. Well, as a matter of fact, the original would have 2 of these in it. But as you can see, there's plenty of room to put 2 of these in there. And then you can just wire it up and it looks original. But like I said, in this case, I'm not really worried about making it look original. Though it would probably be pretty easy to do. But I'm going to tack them in anyways because I may not stick with this 20. I may end up going back with the other 47 if there's too much hum. So right now I'm not going to fool around with this. One thing I did here is when I cut the original leads, I took loads of pictures, copious amounts of pictures, but also when I cut the lead, I didn't cut it all the way to the base. I left some blue sticking out, so I knew that blue one matches with that. And this red one matches with this one right here. Okay, and the black is still attached up here. Okay, in this section what I wanted to do was show you why it's so important to replace these paper capacitors. Even if something hasn't been used for years, it can still go bad. I have a Solar CB60 capacitor checker and resistor checker. And basically how it works is you can read the capacitance by turning this knob here, read the capacitance while looking at the eye tube for maximum deflection, and I'll show you how that works. First of all, we'll start off with the electrolytics. There's 3 electrolytics in this radio. In this one they have 240s in here and 120 here. And we'll start with the one section of the 240s here. And basically you put it on a scale that you want to test. This will be 40 microfarads. So this red scale will read up to looks like 70 microfarads, but we want 40, so it should read around here. And we'll just hook up this to one section. You just put it on the scale, hook up your leads, and you turn this and look at the deflection. See, it's closed. See, to open it up there, I hope you can see that. And then you read maximum deflection and you read the capacitance. And it says just about 40. Okay, so that looks good. Now you rotate this dial all the way to the right, okay, and then you check for leakage. And you set this for 0 volts. This will be 100, 200, 300, 400, 500 volts. Okay. If this light stays on for a long time, the capacitor is leaking. Now this is a 150 working volt capacitor. So the maximum I want to put is 100. If I put it on 200, it'll overstress it. But as you can see, it charges up, and then the light dulls down when it goes down to 0. It tests pretty good. Okay, it's definitely not real bad. I would not use it, but I just want to show you. Okay, we'll put it back on C1. This is another 40 microfarad, so we should see it open up, and we do. Maximum deflection, about the same place, 40 microfarads. Rotate this all the way to the right, put this on 0, and I can go up to 100 but no higher for this capacitor. Okay, that one tests okay. Alright, let's test the third electrolytic. You always want to make sure that this meter is at 0 volts, because if I do this and it's not at 0 volts, I'm zapped. You don't want to do that. Okay, go back to the C1 scale. Now this is 20 microfarads. So, 20 microfarads is around here. This is closed. Now we look for maximum deflection. And, wait a minute, there is no deflection. And the deflection happens here, and it reads open. So this capacitor is open. Internally, it's not connected. So this capacitor is definitely bad. It's essentially not even having one in there. So as you can see, these things do go bad. I did test a couple of others, and they did test pretty good, but I bet there's at least a couple more in here that are bad. It's just better to replace every single capacitor in the unit, because even if it tests okay now, these things are still 60 years old. So 5-10 years down the road, you know, it would be bad news if one of them shorted out. Could kill a tube, cause a fire, who knows what could happen. So anyways, so that's it on that, and I just wanted to show you that the capacitors do go bad. So I will be replacing all these capacitors.